is Dr. John Belkowitz. I'm the Director of R&D at Intelligent Concrete, and we're here to talk about something different today. Totally different. Concrete. So it's not too different, but you know, we like to surround ourselves by concrete that we get to talk about. We have concrete articles on the wall that we refer to every once in a while, either with our clients or just for fun. And that goes for the concrete that we have in front of us. So I've got a desk full of concrete here, and it's concrete from all over the world. And it's also concrete from here too, but it's concrete that we love to talk about. So I'm going to start from, and I'm going to go just to talk about all the concrete that I get to look at every single day. And once in a blue moon, somebody adds a piece, and it's got to be a special piece, but they add a piece. Okay, so wait, this is not concrete. So, the first two pieces of concrete are from two different structures, from two different places throughout the world, and they were built around the same time during wartime. So, both of these were concrete mixes, or concrete from concrete pillboxes. And a concrete pillbox is something that's used in forward military operations. Basically, it's a small, a short concrete structure that can hold anywhere from 2 to 8 people, maybe a little bit more. Has an open front portion for a munitions to go out of, or to shoot out of, without really being susceptible to munitions coming in. And then it has an exit point too, so you can get in and out of, but it's very, very small. All of it's small for cover, concealment, and deception. This is off of the coast of San Francisco. This is off of the beaches of Normandy. And there's a color difference between the mixes. There's an aggregate difference. There's a density difference. You can definitely feel the heavier density in the concrete you can hear, or from the San Francisco concrete versus the beaches of Normandy. And the biggest difference, this was the beaches of Normandy. When the Germans were putting this together, it was under inclement conditions. It was under wartime or duress. When this was made in San Francisco, it was wartime, but it wasn't at the forward position or the front line. So definitely had more time, can use materials in a more efficient manner to get a more dense mix to create a structure that is stronger and that would last longer. Okay, so that's these two. This one goes along with this one. So we work, with a 3D printing company, an amazing company that is trying to end homelessness throughout the world using 3D printed concrete structures. And I've already done videos on that, and Haley, if you wouldn't mind putting the link down below. I get a little emotional about that project. It's one of the most beautiful projects. So the first mix that we ever did with them, we didn't have a 3D printer, so I took a grout bag and I did my own 3D printing with layers, and I actually had a time scale behind it to watch the consolidation of it over time. And as I was putting the equipment away, Whitney cleans off the 3D print. So I came back and I redid it, but I didn't do it as extensively because the mix was already old and it was harder to print and harder to push. But yeah, this was the first time that I ever did my own 3D printing with a 3D printing mix. And this is one of the first true pieces of 3D printed concrete that I've ever worked with in my life. And this is with that company, Icon. And we started working with them. They were using a mix that was subpar, but the team at Icon is so strong in taking something that is barely on the edge and modifying that construction material so that it could be pushed out of the nozzle at a perfect bead. And that's what you see right here, that perfect bead that has that successive adhesion between layers. And one thing that we had Brooke do is, you can kind of see it over here when we cut it, or when it was broken, but over here where Brooke cut this portion out, you cannot see the difference between layers. So there literally was a successive adhesion between successive layers of our 3D printed cementitious ink. Really impressive stuff. Okay, so going down the line. Okay, so this one, when I was when I was still working for Lafarge North America, I had this huge studio apartment. And when I say huge, it was in a pretty bad part of town. But you know, ceilings were up to here. It was an old military base that was converted into an apartment complex. And had a big closet in the front. And I took this closet and I converted it to a lab. Everything from putting a bench in with a mixer, and I would call these companies, and I was still in school technically, so I'd say, hey, I'm a college student, I'm trying to, you know, come up with these formulas, can you send me free materials? So I used to get free materials, and I made sure not to do this at my place, or the place that I worked, because then they would own it. So I did this in the lab. I didn't have any safety equipment. And some of these materials, I would open up the bags and I would immediately start coughing. So not really smart what I did, but definitely you know, put that time and effort into something that I loved. Well, anyway, I didn't steal, but I borrowed the molds that we had, because I was just starting out with this research and development, like getting into it. And I didn't understand the concept of making small samples. I only knew how to make big samples and slabs. So the company I was working with, Lafarge, were making these pucks of concrete using Lafarge Agilia, and they were these silicone molds that you could reuse. So I only used it once, one time, and I made this floating concrete with it. And this was my lightweight self-consolidating concrete that I made 1 February 2006. Yeah, it's just funny because it actually has the Lafarge Agilia logo on it. And that's what I was designing at the time. So this is not Lafarge Agilia. I just borrowed it. I brought it back. But yeah, I thought it was pretty cool. So anyway, so this piece of concrete. Oh, let me do this one first. So this one is a piece of concrete from Bellefontaine, Ohio, off of Main Street. And this was from the first concrete highway in America. And I believe it was built in, I want to say 1919. It could have been 1819. I don't know, there's a 19 in it. But Whitney and I don't think we did a story time on this. We went to go visit it one time and ended up in the wrong state. The second time we went purposely out there, and there were some pieces of concrete that were broken up that I took. One for me, another two for some good friends of mine. And listen, it was going to be tossed out, broken up concrete. I feel guilty for doing it. But you can see just the, I mean, you got the crushed up aggregate in here. You know, there is what looks like air in there, but it's not like the Aaron type or Aaron training agent that we have today where you can barely see the air bubbles. These are big, big air bubbles, so something else was used to get this, not what we have today. And I mean, this most of the aggregate that I'm seeing is, you know, pop-outs or pull-outs. So there is some broken sections of it, which suggest a good interfacial bond. But the amount of water that had to be used, the expectation should be that there would be more pull-outs. No matter how old the concrete is, 100 years old, you can't get away from that high water cementitious, that weak interfacial bond, especially if you're using crushed concrete aggregate, that in that time they might not have washed, so you're going to have that weak interfacial bond. So it's really interesting stuff. So the next piece of concrete is from the Hoover Dam. Literally, this is a piece of the Hoover Dam. And to hold this, oh, it's to hold a piece of history, American history. And if you've never read, you know, Joseph E. Stevens' book on the Hoover Dam, I think it's called The Great American Journey. That's a book that you have to read. You have to read that book before you go meet Katie Bardaget. And it's not on Audible. So I don't know if you know how to read, but you should have some time. Yeah, it's tough. Kids nowadays, you know, those millennials, who knows if they know how to read. So, but, you know, Katie was gracious enough to, Katie Bardaget works there, known her for a very long time, and I've been asking her for over a decade. I would say 14 years I've been asking for a piece of the Hoover Dam. I've even threatened to steal 500-pound samples of the Hoover Dam. I always have to ask for a dolly. You know, I need to borrow a dolly for them to steal the sample, so I never really get to steal the sample. But Katie gave me a piece of the Hoover Dam concrete, and she doesn't know this yet, but years ago I was given a piece of Roman concrete from an aqueduct in Israel. And I've done some scanning electron microscopy on it to look at the hydrated cement matrix, and you can actually see what looks like, and I really need to get somebody to check out these pictures, but what looks like almost like barnacles surrounding the hydrated cement matrix. And you can see that optically, you can see that greenish look to it, but we're going to cut this in half, and I'm going to surprise Katie with this. This is just she gave me a piece of history, and I want to give her a piece of concrete history back.